notice the name of my talk is not exactly what you have in the schedule. Originally, this talk was going to be delivered by Stephen Feuerstein, so I apologize to those that may have been expecting a different bald guy. This talk is similar but a little bit different. Stephen, of course, being the PL SQL genius he is, would likely go more in-depth in that particular area. I'm not going to do that. I'm going to stay very high level and talk about a lot of what Oracle's been working on with respect to JSON and tooling for JSON so that you guys can work with JSON with Oracle Database. I have to show the safe harbor statement, but I don't intend to show you anything you can't already do today. I'm going to cover features that are new in 12.2, and of course there'll be in 18 and just continue to get better. But just in case, don't make any purchasing decisions based on what I say. So my name is Dan McGhan. I work on Stephen's developer advocates team at Oracle. I focus primarily on the JavaScript and database communities. The intersection of those two right now seems to be Node.js, which is a JavaScript platform for the mid-tier. And I'll show you a little bit about that today, although it's certainly not going to be the focus of today's talk. So this is a brave new world we're in today. The world we came from is quite different. We're all familiar with the relational model. This is based on logic and mathematical theory made by really smart people who knew what they were doing. So for example, imagine that this is a table and we're storing data like this in tasks. If you look at it long enough, if you analyze the data, you might see some anomalies that we normally wouldn't do in our tables. So the first one that probably jumps out at folks is I have multiple pieces of information in a single column. That's no good. And you might see repeating data as well. And so if we make a change to one, we have to be very sure we make the change to the other as well, otherwise we get inconsistent data. And as you stare at it long enough, you realize really what we're looking at are three different entities in the data set. So the first, of course, are the tasks that we're really concerned with, but we're also looking at project-related information, and we're also looking at information related to people and where they live and so on. And so with the relational model, what we've learned to do is to break these up into separate tables. And then we can bring them back together by adding foreign keys to some of these tables and linking them back like this. So in this case, I have two foreign keys pointing to the people table. Another way we could do that is with a lookup table. This is sort of an art, and there's no set way to do it. I struggle, for third normal form. Some people maybe a little bit more, some people a little bit less. But this is that process of normalization. This is how we've learned to store data. Then we can use the power of SQL to bring it all back. So, of course, we can do a simple query on the tasks table to get some of that data. We can then join to the projects table to get project-related information. And now with the power of listag, everybody here using listag, we can actually bring some of that duplicate data back into the column level. So we're storing and retrieving data in the most efficient way possible. Mid-tier developers, JavaScript developers, they don't care. They couldn't care less. What they want is JSON. And there's a reason for that. It's just easy for them to work with, very, very simply. So what is this JSON? Well, it's based on structures. So you have object and array. JSON will always start with an object or an array. The objects are made of key value pairs. They're quite simple. And the value portion of those could be any of these. You're going to have either a string, number, Boolean, true or false, or null. That's really all it is. The value could also be one of these structures, object or array, and that's how the structure of JSON becomes recursive. But it really is just that simple. So if we look back at that tasks data set, and we try to envision perhaps at least the first row as JSON, we'd end up with something like this. So note here that I'm starting with square brackets, so we are starting with an array. And then inside the array I have an object. Now obviously the ellipse at the bottom is not valid JSON, just indicating the continuation of elements in the array. And what we have in the array is just objects. And so the objects have keys. You see that they're in double quotes. Then we have colons. The colons are separating what comes after them. the value portion. At the top and the bottom of this object, we see examples of numbers. The numbers are just numbers, they're not in quotes. And of course, we have a bunch of strings as well. JSON's really just that simple. A couple other notes. It is schemaless. So you can have an array with a string followed by a number, followed by an object or an array. That's completely valid JSON. Also, there is no standard for handling dates. When I talked about those data types a moment ago, did anyone hear date? No. I don't know why that wasn't covered. It's kind of an important data type. Most folks are using ISO 8601 standard, so you just convert a date to a string. Some folks are using epoch time. It's really up to you, but I recommend the 8601 standard. If you do use that standard, just note the Z on the end. What's that stand for? Zulu, which is the same, essentially the same as UTC. So you need to do your time zone conversions using the correct tools for that. So let's talk about these front-end developers. All they want is JSON. The question is why? And the answer is all they need to do, this is a few lines of JavaScript code. They can declare a variable, and then they use some kind of API to get JSON data. Generally, it's going to be over some web service. And they have JSON.parse built into browsers or other tools are using, maybe handsets or like iOS devices, Android devices. And once they do that parse, the JSON is converted to an in-memory structure that they can then work with, a native structure in their language. So in this case, JavaScript, so we have tasks, and then we can start to iterate and work with the tasks. It's all about simplicity for them. Who here has used ORDs so far to create a REST API? Okay, just a few. So obviously, if that's the way they want their data, we need, as Oracle developers, to be able to supply these developers with that data. So let's talk about REST. REST is short for Representational State Transfer. It's basically the architectural style of the web. Been around for a while. When Roy Fielding wrote about this years and years ago, he defined 6 constraints. These are basic constraints that make a lot of sense when you think about developing APIs. They got to be stateless and cacheable, layered, and a lot of them are built around scaling. I've never actually seen anyone use code on demand, but all the rest are pretty standard. Clients, the way REST essentially works, if you've never used REST before, you're basically exposing URLs, and they're going to be based on nouns and not verbs. So in the past, if you were doing RPC-style development, you might have created an API that said get employees. With REST, you don't do that. You just have nouns, and generally you're going to expose a plural noun in the URL. And then the way folks would get a list of employees is going against the employee's URL. And if they wanted a single employee, then they would just add a slash followed by the ID of the employee that they're after. The reason we don't say get employees in the URL is because we have HTTP methods that are used for the verbs. And you can see these methods here. These are the most common HTTP methods you'll be working with in a REST API. And you can see the CRUD or SQL database operation listed here as well, how they kind of map for the most part. So if you do go to develop an API, a REST API, you're going to have to make a decision about how you want to implement it. You could roll your own, and that means you're starting with a low-level language such as Java, JavaScript, and literally build it up layer for layer. If you're going to take that approach, chances are you're developing the REST API that's like the flagship API for your company. You plan to expose this to the public, and of course, having that approach from the ground up gives you a lot of control, so it might be a great idea. However, it takes a lot of work to get that done. So if it's not that flagship product, maybe, for example, you're building REST APIs for developers working on departmental apps. So you don't need it to be quite as exact. That's where frameworks come in. They can jumpstart the development for REST APIs, make it a whole lot easier than it would otherwise be. There are all kinds of features you can build into REST APIs. So if you do take the roll your own approach, you will be working quite a bit to get that done. Pagination sorting and filtering is kind of like the bare minimum that any REST API is going to need to support. But of course, there are many other features. one of the great things about using a framework is that you often get all of these features out of the box. So this is where ORDS comes in. ORDS is short for Oracle REST Data Services. This is a tool that Oracle provides free of charge for exactly this purpose, creating REST APIs. It is a Java-based application, meaning it's going to run in a Java application server and a middle tier. It's not built in or baked into the database. So you'll need to have something like Glassfish or choose your mid-tier there. But it supports Oracle as well as the NoSQL database, and we can even use Oracle now as a document store, as I'll show you here in a moment. I'm not going to go into the detail on this slide. This is really just to show you that ORDS has been around now for quite some time. It actually started as the Apex listener. So any Apex folks here? Oh, wow, quite a few of you. So Apex is obviously a great tool for building web apps on Oracle database, but it doesn't work without some kind of web listener. So we needed that, and that's what it was originally built for. It was called the Apex listener, and then when Apex added support for JSON, they realized that that's actually quite important, and then they repurposed the tool, or really just refocused their efforts on that JSON support. So over years, they've been improving it. The most recent feature that I love from 2017 is called REST-enabled SQL. We jokingly call that SQL injection as a service, but it's not meant to be exposed like directly to clients to work with. It's meant to be in a mid-tier area. So you could use ORDS standalone, as you see here, and you're, of course, working with clients directly, or you can use ORDS as though it were like a database driver technology. You can set it up in the mid-tier and have other mid-tier technologies working with it. I think this is really more the aim of that SQL injection as a service. You're going to have an authenticated user here communicating with ORDS in that way, not a client directly, unless, of course, they're authenticated, but that's probably not going to be the primary use case. So everyone here should be familiar with the HR schema. This is how a lot of folks learn to work with Oracle and SQL. And one of the interesting things is that because it's relational, we can do things as we choose. If we need to expose to our developers the HR schema is JSON, we actually have to kind of decide the best way to do that. So you might start with employees, for example, and work your way down. So you're going to have an array of employees. Each employee has a job history, and that relates to jobs. Each employee belongs to a department, which has a location, country, and region. You might do that, or maybe you're going to start with departments. And so departments have locations and employees and so on. The point here is that because we store data as we do, it's very flexible. We just have to figure out how to best expose it to the end users. This is an example of the last one you saw. So if we're exposing departments, and this is just one department, what that might look like from the HR schema. So literally this is just a single object, but we might, of course, return an array. And the question is, how can we get this done? So I'm going to show you a demo of ORDS. So a lot of folks don't know this, but SQL Developer actually comes with a version of ORDS baked in. So when you go to SQL Developer, if you go to Tools, to REST Data Services, you'll see options to work with ORDS. You can install ORDS or uninstall it. I'm just going to run it. And I said a moment ago that ORDS runs in a mid-tier, but it can run standalone as well, which is very useful for doing local testing or demos like this one. So I'm going to start ORDS, and I'm telling it to listen on port 9090. So what it needs to do is start up a connection pool to the database. Can't see all those messages. Let me move this around some. All right, so at this point it says it's started and running. So what you can do with ORDS is go into a schema, and once you open the connection, if you right-click on the schema, you can come down to REST Services and go to Enable REST Services. Now, generally speaking, as I said, you're going to want to authenticate, but that doesn't work well for quick demos. So we're going to disable authentication and enable the schema. If you don't want to expose the schema as its name is in the database, you can change that here. And just really quick, what I want to show you is that all this GUI and SQL developer is doing is making API calls to a package. So you don't have to work with ORDs using the GUI. You can do it all programmatically with PL SQL if you choose. So we've enabled the schema. And what I'm going to do is go into a little tool that I like to use when working with REST APIs. This is called PAW. PAW, unfortunately, is Mac only, and it's not free. But if you're on Windows and don't want to pay for something, there's a great tool called Postman that you can use. Very, very similar tools. So what I'm going to do is issue an HTTP GET request on this URL. So localhost, remember I told ORDS to listen on 9090. ORDS is just the starting point of where ORDS is. HR is the schema that we exposed, and employees is the table I'm going after. So I'll fire that off. We get 404 not found. That's a good thing. If you enable a schema, you don't necessarily want to expose all of the tables within that schema, right? So ORDS isn't going to do that. We've only gone in and enabled the schema, but at this point we can go into the tables. We can say, all right, employees, again, right-click, come down to Enable REST Service. We'll enable the object, disable authentication, finish that, go back to PAW and try it again. And now we're getting our JSON data back. So this is just an example of auto REST enablement. I haven't written any code here, but you see how easily I can come in and enable a table, REST enable a table with just zero code. This is what frameworks can do. They can do quite a bit. So I can obviously go over or after single employees just by adding the 101, which is pretty standard. Now we're just getting a single employee back. But what's really great about ORDS is that, remember when I said sorting, pagination, and filtering are kind of like the bare minimum that any API is going to need to support? Well, of course, ORDS has that baked in. The way that ORDS does it is using URL parameters. So you're not seeing it in the base URL here, but if you look at the curl equivalent down below, you can see the actual URL that is being issued here. So limit and offset are what we use for pagination. Everything else comes in through this Q parameter with ORDS, and it's actually a very powerful parameter. So it has the ability to do filtering, and what you're seeing here is essentially serialized JSON. You couldn't type this directly into a URL because it needs to be URL encoded, as you see down below, but we can see it here a little bit easier. So if I issue this request, then we're just getting 6 items back, and these are the folks that have AN and their first name. So we can do filtering. There are operators for ordering the data as well, and as I said before, for pagination. So you get all this out of the box for free. It's fairly well documented. The operator you're seeing here, nstring, is just one of many. So there's all kinds of different operators that you can use to filter your data, or really the developers can use to filter the data. If you needed to get the JSON as we saw it, which, if you look back at that slide, this is hierarchical JSON. It has more than just a single table would include. You can use ORDS. There's a section of SQL Developer for REST development. You can do custom stuff as well. So if you have a query, and I'll just show you what it might look like, you can expose a query like this as JSON. So what you're seeing here is about as close as I could get it to the example I showed you before. The neat thing is that we can do nested JSON with ORDS using cursor expressions in SQL queries. So here you see I'm going one level down, another level down, and I'm able to use this rather complex query to convert all the departments in the departments table to JSON with a lot of other data from other tables. I can then expose this as a REST endpoint with ORDS, and then ORDS will basically wrap our query, treat it as a subquery, and then use that Q parameter as needed by the end user. So filtering on that data, sorting it, and paginating. Any questions on ORDs? Okay. Oh. Sorry, just one second. I'm going to shut down this VM. And start up the one I need for the next demo. So as soon as you expose your new REST APIs to the developers, they may come back and say, well, that's great, thanks, but we still have to go back to you to add columns. Developers have really enjoyed working with Mongo, primarily because they don't have to work with a DBA. But of course, once you start working with Mongo, you introduce new systems that have to be maintained, backed up, recoverable, all this kind of stuff. So what Oracle's done is introduced SODA. Anybody worked with SODA? Couple folks. So SODA is short for Simple Oracle Document Access, and this is Oracle's solution or answer to Mongo, essentially providing a NoSQL API to work with Oracle Database and JSON. The JSON is stored in traditional tables, but it's all managed by the end users, and you can even do like query by example, as we'll see in a moment. When you start working with ORDs and SODA, you'll see that you have a schema root, which is typically going to be ORD schema latest SODA. Latest meaning the latest version of ORDs and the SODA APIs, although in the future if there are backward incompatible releases, you might have to specify a version if you want to continue working with it. But you have all of these endpoints to start working with data, not having to go in at the SQL layer, just using HTTP and REST. So let's take a look at SODA. So the first thing I'm going to do is go into my database as sys, and I'm going to run this code. So we're going to create a user called SODA demo user, and the important thing to note here is actually this last grant here. If you want folks to be able to work with SODA, you need to grant this particular privilege. So we'll run that script. And now we have the SODA user.
What was the first version of Oracle database that supports this?
The question was, what was the first version of Oracle database to support this? It's a good question. I apologize, I don't have the answer. I believe it's supported up to 11. So the way that SODA is being approached, when it was first introduced, we had native support in Java and REST. And the rest really came through ORDs via Java. But those were the first two. But SODA is being developed in the C layer and will at some point be exposed. We use C layer APIs to build features and functionality for other scripting languages such as JavaScript. So SODA is going to have APIs in a number of other languages once these layers are in place. But I believe the REST functionality can go back to 11G. For the other stuff, you might need another version for like PL SQL support, for example. All right, so we'll get connected as the SODA user. And I'm going to run two commands here. So the first one is just deleting a privilege mapping. Don't do this in production. We're doing the same as I did before, and I'm just disabling security. And then the next thing I wanted to show you, or the first thing rather, is just enabling the schema for SODA. So we'll run both of those. And then I'm going to restart ORDS. All right, looks good. And then we'll open up PAW again to work with Soda. All right, so the first thing I want to show you, actually, let me go back into this user. Right now, note that the Soda user does not have any tables, right? So just over REST, what I'm going to do is issue a put where ORDS is listening, the Soda demo user, and I'm going to issue that put against employees. And you can see it's exactly that simple in this request here. This is to create a collection. So when I issue this HTTP or REST call, oops, let me try this again. Okay. So you see it comes back 201, success created. If we go back now to the schema and refresh our tables, you'll see what it's done. It's created a table called employees. And if you look at the definition of this table, we have some metadata columns as well as a JSON column, which is going to store JSON as a blob. Now, the reason I said you don't want to disable security in production, as I did, is because you can issue an HTTP delete on that same endpoint, and the table's gone at this point. So keep that in mind. This isn't something you just expose to end users directly. This is something used in the middle tier by developers. So I'll recreate that, and we'll move on. Now, what I want to do is get some JSON into that table. So for that, what I can do is issue a post against our employee's endpoint. And what I'm posting here, it's probably easier to read as text. Make this a bit bigger. I'm posting a JSON document. Down below, you can see what the curl equivalent would look like. And we fire that off. And what we get back, it's created now. So there's now a row in that table. And of course, the content is in the JSON column. And what we get back is an array. In this case, I just did a single document, but I get the ID of that document I just created. And what I can do then is use that ID to fetch that particular document back out, so you can see what that looks like. And there are lots of interesting APIs built in. So for example, in this one, I had to use a URL parameter action is insert, but if you look at the content, oops, and view it as text, you can see that now what I'm doing is inserting an array. So the first one I inserted was myself. Now I'm inserting the rest of my team. So here's Blaine. He knows a little JavaScript, also Python. Here's Chris Saxon, SQL and PL SQL primarily, and Connor, SQL and PL SQL, and then you get to Steven, just PL SQL. So if we fire this off, oops, let me go back to JSON, fire that off. So we get 200 OK, and you can see I'm getting the IDs back for these new documents. Now that we have 5 documents in here, what I wanted to show you is query by example. So we want to retrieve certain documents but not others, and there are APIs for this as well. So let's say I want to get just the folks that know JavaScript. So in the body portion here, the text, the query looks like this. So I'm saying languages in JavaScript. So I can issue a post against this URL. Switch that back to JSON. Fire that off, and now you're only going to get myself and Blaine coming back. So with an API like this, developers don't even need to work with DBAs. If all they want to do is a really simple type of application, they want to store some JSON, they want to retrieve some JSON, they want to be able to query the JSON, all without having to go to a DBA, all you need to do is enable Soda and just give them the power to do so. So ORDS can do both of those. So as you're getting more and more JSON in the database these days, and this can happen a variety of ways, you just saw a couple, but there's others. So for example, you might be working with different systems such as social media these days, storing information about tweets folks are doing about your company and want to analyze it. All kinds of ways JSON may end up in your database. When it does, you're going to need to be able to query and analyze it, of course. So Oracle's been investing a lot of time and resources in giving you SQL capabilities for this. So as far as querying goes, there's two basic mechanisms for working with JSON and SQL. One's a simple or simplified syntax, and then you have a number of operators. Here's an example of both. So on the top, we're using the simplified syntax, and you see in the where clause, I should say that first, when you create this table theater, you would have to enable the isJSON constraint. It's like a magic constraint. In addition to ensuring that the data going into the table is valid JSON, it also enables some functionality such as the simplified syntax we see here. So it's not going to work without that constraint. When you have the constraint enabled, the alias of the table there, T, is required. So we're saying t.json document, which is where the JSON is stored, .id. We can access properties within the JSON using that syntax. It's simple, works for a lot of stuff, but maybe not everything, so that's where we get into JSON operators. So here you're seeing JSON value both in the select and where clauses, and as you can see, they work with JSON path expressions to query data out. This is perhaps a lot more powerful and flexible. As you'd expect, in a relational database, if you're storing JSON data in different tables, you can then join it back together as we've always been able to do in SQL. So you're just seeing the simplified syntax used here to do that, and then we can view the data back in a normal relational form. We can expose it to the existing reporting tools and other tools that we have in the ecosystem. Here we have some of the operators that you have available. Now, a lot of folks, I mentioned the isJSON constraint. A lot of folks then start working with these, JSON value, query, and exists. JSON table is really the powerful one. And of course, text contains is a nice search functionality. JSON table is nice because you can take JSON data and use it to expose that data as a relational view. So you can store it as JSON, but make it really easy for folks to query relationally. Here's an example of how it works. So you take the table, theater in this case, that contains the JSON, and then you use an Oracle join to it using JSON table. And so you have the column there, JSON document, your JSON path expression, the starting point that you want to look at, and then you have a columns definition. So you're able to specify what the column name is, its data type, and then the path to that particular data in the JSON. The reason I said that this is perhaps better than using functions like JSON value, if you have let's say you're doing a select and you're saying JSON value 3 times in your select clause for these different path expressions, JSON value is going to parse the JSON document 3 times for each row. It's just not efficient. With JSON table, it's a single parse and then exposing the columns as many as needed. So this is definitely where you want to go. If anyone here is using some of sorry, I got ahead of myself. JSON search index is also something you can enable. It's a full search index. So all the kind of capabilities you're used to in that are supported with JSON. This is new in 12.2. And if anyone here is using Exadata, the Smart Scan technology does now work with JSON. And there's also an in-memory column store. And what's nice about this, as the JSON data is read from disk and in memory, it's converted to a very efficient binary format for JSON. So of course, queries go fast. There's also another new feature in 12.2 called JSON Data Guide. So JSON Data Guide is all about basically exploring and learning about the JSON that's coming into your systems. Especially when you're working with third-party JSON, say from Twitter, it's kind of hard to know exactly what is going on in the JSON, and it may change over time. It's hard to keep up with that. So that's why Oracle's introduced JSON Data Guide. JSON data guide just returns a clob. So as you see here, we're querying, it's an aggregate function. We're querying a table that has some JSON data, and we get back this array that describes the JSON data. If you use the hierarchical version, it returns JSON schema. This one that we're seeing here is a flat version of it. But as you can see, you're getting JSON path expressions, data types, and then a length, which tells you a little bit more about the JSON data in the database. This is an interesting trick where they're using a common table expression, so building on top of existing JSON functionality. So JSON data guide is being used here to generate that JSON schema you saw, and then JSON table is being joined to that to display the data in an easier to read format so you can see the path expression, data type, and length. And using the JSON data guide, once it's created, you can leverage the new DBMS JSON package to create relational views automatically based on the JSON data guide. All you need to do is tell it the starting point. In this case, the path is $ID. And then from that point down, it creates a relational view so that you can start to query it using standard SQL automatically, which is great. And you can see an example of that here. If you don't want to do the view, if you'd rather work with virtual columns on the table that contains the JSON, that's also supported using DBMS JSON. And there's this nice feature. Let's say it's important to you to track changes to JSON over time. There's support for that built in already. I think a good use case for that would be, let's say you're exposing data as soda, and API developers are working with the JSON. Over time, especially in the early stages of an API, they don't even know what the data is going to look like. But at some point in the future, they might say, all right, this is pretty much the schema. And you can say, all right, we're going to use JSON data guide to crawl the data, get an idea of what it looks like, and expose it to folks. But then, of course, it could change over time. So this is a really nice way. You can create a table here called JSON changelog and a procedure that just does an insert into that log. Now, the procedure that you create does have to have this signature, but what you're getting access to is essentially the event of a change. And the way it works, you create a JSON search index on the table, and inside of this you can say, on change, invoke the stored procedure that you've created, and then as changes occur, on commit, on insert, or update, on commit, JSON data guide gets updated. If there's a change, invokes your procedure logs the change, so you get access to that change over time. Take a look at JSON data guide. Oh, yes, okay, so this is a risky demo, but I'm going to do it anyway. So we're going to start in the HR schema. And I'm dropping a table called tweets and recreating it. As you can see, it's a simple table. Just has a clob column to store the JSON data. And as you can see below, what I'm doing is adding that check constraint for is JSON so we get the JSON capabilities. All right, so at this point, obviously our tweets table is empty. What I'm going to do is start a node application, and while that's running, I'm going to show you what this node application looks like. So this is JavaScript. It's about, zoom back out here, 73 lines of JavaScript, and what it's doing is bringing in a library called Twit. That's for working with Twitter. It's bringing in Oracle DB for working with Oracle Database. And we're using startup here to kick things off in the code. Now, the first thing I'm doing is using our Oracle Database driver for Node.js to create a connection pool to the database, just 3 connections. Once that's done, I enable a Twitter stream. So what the Twitter stream is doing is using that Twit library to connect to Twitter. And then once we have that in place, I can set up an event listener for when new tweets come in. And the tweets I'm telling it I'm interested in are those that involve Oracle, Oracle Code, or Oracle Apex. And when a tweet comes in, I get the tweet, and I'm incrementing a counter. And unfortunately, I'm not seeing it increment here. As I said, it was kind of a dangerous demo. I'm wondering if we have a problem with the internet. Oh no, this isn't good. Let me see if I can get my personal hotspot to work, but it doesn't seem to have much. This one seemed to work. Let's just give it a shot. I'm going to kill the Node app and restart it. All right, let's let that run for a bit and cross our fingers. So when a tweet comes in, what should happen, I'm incrementing a count and logging that out. So we're seeing it now. We're seeing tweets coming in. And then I'm just taking the tweet that comes in, and I'm saying insert into that table I've created, this tweet essentially, just binding that in. And that's all it takes. And so at this point, you can see wow, hopefully. Perhaps I'm giving it too much to do. Let me kill this, and I'll disconnect from Wi-Fi. Unlikely. The way that Twitter API works, it's essentially it's an evented system. And so you couldn't just go to Twitter and say, hey, give me the latest tweets like that. So you would need an API that's designed to work with Twitter's API. So chances are that won't be developed in PL SQL. It would be developed in a mid-tier technology such as JavaScript, as I did.
They wouldn't have something exposed that
Not that I'm aware of. No. No. Maybe they have something like that that allows you to go back over a certain amount of time. I just haven't seen it. All right, so at this point, if we look in our tweets table, boy, this is not going well. You can see that we're collecting tweets, and if you look at the content of a tweet, what you'll see is that Twitter is sending you data, and you have no idea the shape of that data. And we're looking at a single tweet here. Different tweets can have a different shape. So the question is, how are we supposed to handle this kind of thing in the real world? This is just one example. So this is where JSON Data Guide comes in. So we can start just getting a basic idea of the data by running JSON Data Guide and getting that overview or metadata about the JSON data. So if we look at this, it's kind of similar to the Twitter data in that it's still kind of complex and hard to work with, but you're starting to get an idea of what you have in that data. So you're going to have JSON path expressions, you're going to get the data type, and then sort of a max length of the data that was sampled. What we can then do is use JSON data guide to make things a little bit easier. So in this case, I'm saying data guide on for this here. I'm enabling the search index. Oops. So with that in place, this failed on me earlier. I think I may have a problem in my database. Yeah. This should work. Basically, your data guides are then stored and exposed to you via some new views, such as user JSON data guides. But what I wanted to show you is that now that we have the search index enabled on it, if new JSON arrives, a new property, for example, in this case, I'm inserting an XYZ property of true into that table. Once we do that and commit, JSON data guide is then going to have the latest and greatest version of that data. This time I'll show you the data using the hierarchical version. If we search this for that XYZ property, you'll see that JSON data guide is maintaining that as the JSON's changing live. So what JSON data guide makes easy is creating these relational views. So you could do something like this and use JSON table to query data out once you know the data you're going after. So here we're seeing some of the people that were tweeting. Or you can use DBMS JSON to automatically create views for us. Now, in this case, I'm just starting at the root of the document, but you might use several JSON path expressions to create different views and kind of view the data in different ways. If you go at this level, it kind of explodes everything out. But if we describe the view it creates, you'll see that it has tons of columns for all of the properties that are in the JSON data. And then you can start to query that data out relationally. So here we're seeing all of the data in a relational format. And this will show me the folks that have geo enabled with their Twitter, with their tweets. If we're getting Latin Lounge, I can detect that here just using standard relational constraints. The columns are case sensitive, so you'll need to wrap those in double quotes. That's JSON data guide in a nutshell. Any questions on that one? All right. So you have ORDs to expose relational data as JSON. You have SODA to expose an API that folks that want to work with JSON only and not deal with the DBA can use. They can take advantage of SODA. You have SQL enhancements to then query data out and data guide to explore the data. And we also have accessing data, so generating JSON from relational data. ORDs can do this for you, but you don't have to use ORDs to do it now. This is baked into the SQL engine as well as of 2.2. These are the main functions you'll use, JSON array and JSON object, as well as some aggregate equivalents. So in basic example using JSON array, you're going to get one array per row in your result set. JSON object will give you one object for each row. But you can use, for example, combinations of these where we're using JSON object and then a subquery with JSON array ag to create an employees array within our result. And here's the equivalent with an object AG, getting a single result and sending that back out to clients as JSON. And we also have PL/SQL extensions. Now, this is probably where Stephen would have gone a lot more in depth than I will. But basically, we now have new support for working with PL/SQL natively. Prior to that, this is a 12.2 thing. If you were using 12.1 or before, you were probably going to take advantage of Apex JSON or PL/JSON. Is anyone using PL/JSON? Okay, that's good. There's actually a problem in that when they introduced these new types in the PL/SQL engine, there were some name collisions with what was already out in PL/JSON, so you'll have to be aware of that. But basically, these are the new types. JSON element is considered the superset or super type of all of the others, but you're rarely going to work with that. You're going to work with object array, scalar, and key list. And the basics are you're going to use parse if you want to take JSON and get an in-memory representation of that JSON to work within your PL/SQL code. And the reverse of that is going from in-memory to a serialized JSON version of that data, and you can do that using stringify and then methods like toString and so on. There's some introspection methods that can be important because as you saw before, JSON schemaless, maybe you don't know, you're iterating through an array, you don't know exactly what it is you're working with. So you can ask, you can say, is this an object, is it an array, and so on. There's a getSize method, which is going to be different depending on what you're working with. So we have scalar here, it'll return 1. But if it's an object, you'll get the number of keys in the object. If it's an array, the number of elements in the array. In a nutshell, by default, what Oracle's doing with errors in JSON is what a lot of other folks are doing, ignoring them. But if you want, if you want to know what's going on, you want to have better control over that, then the capabilities exist. And of course, when we make these slides available, you'll have some of these notes. So hopefully everybody's familiar with Live SQL. Stephen has created examples of how you can leverage this functionality in Live SQL. Here's an overview of working with JSON object. And he's saying to go search for JSON object T in Live SQL. So I'll just show you that real quick. So if we search for that, you'll see the code examples that Stephen set up. So here's one where we're declaring a new variable using that type, JSON object T. And as you can see, it's the object-oriented side of PL/SQL. So we're able to then parse some JSON. And now LObject is that in-memory representation of the JSON. That will have methods, like in this case, getString, that allow you to work with the JSON data in a programmatic way. And he goes on and on with a ton of those examples. I'm going to skip the detail on arrays and just point out one more resource you can use if you're interested in learning to do this on your own. Again, it's using Live SQL, but unlike just the examples that Stephen's put out there, there's an entire tutorial that you can use to learn about this functionality. And the way you get to it, just go to Live SQL, go to the bottom where it says View Scripts and Tutorials, and filter on Tutorials, and then search for JSON. And you'll see this SQL JSON features in 12.2. And basically the way the tutorials work in Live SQL, you have the content on the right and you're just reading through it. And when you come across code samples, there'll be a button in the bottom to put that into the editor. And you have, of course, access to a 12.2 database So you can learn about all of these features as you need. At the end of the day, there is no escaping JSON. For developers, this is going to be the preferred data interchange format for years to come. It may change, but this is it for now. At this point, with 12.2, Oracle Database has a lot of functionality to allow you to expose JSON data, to work with JSON data, to do whatever it is that you need to do with JSON data. So hopefully, you can help your users be successful and be successful yourself. Any questions? Not a single question? Well, in that case, you can find me after. I'll be happy to answer them. Thank you very much.